outcome. Each result is an outcome. And set of all possible outcomes is called the sample space. Okay. So what is that one? Set of all possible outcomes. Set of all possible outcomes is called the sample space. Okay. Each element of sample space is called a sample point, or also simple event also. What they call? Simple event. Sample point or simple event. Okay. So here this is. So what happened? All possible outcomes you need to write. You need to write all possible outcomes. Now, two coins, a 1 rupee coin and a 2 rupee coin are tossed. What is the sample space? What is the sample space? So I will write the sample space as like this. Here 1 rupee coin, here 2 rupee coin. Okay. You will be getting the possible outcome is head and head is possible. Head and tail is possible. Tail and head is possible. Tail and tail is also possible. Okay, this is the sample event. Now just I'll tell you, these are all possible events. Now if I say number of ways of getting 1 head plus 1 tail. So what happened? These are the two things. So if I this I say event E. So what is the probability of E? I'll say number of favorable cases. How many favorable are there? 2 are favorable out of 4. So answer is 1/2. That is the probability. That's the probability. So simple. Okay. Now look at here. When a coin is tossed twice, and if head appears in the second throw, then the dice is thrown. Write down the sample space. So you need to write it carefully. A coin is tossed twice. If the head appears in the second throw. So first one is head, tail and tail. No problem. Head. Then next throw is throw. Next throw is tail. No problem. Tail, you draw head. Then you need to write the what happened? Dice. So what will happen? TH. 1 is possible. TH. 2 is possible. TH. 3 is possible. TH. 4 is possible. TH. 5 is possible. TH. 6 is possible. Now head. Then because it has head, because if head appears in the second throw, the dice is thrown. Head 1, head 2, head 3, head 4, head 5, head 6. Okay. So write all possible. So how many things are coming, you need to check. If it is the second throw is the tail, you need not worry. If it is a head, then you need to go for the throwing the dice. Now, we are moving to the next one. Event. Read it carefully. So please read out what is the event. So sample space, any subset of sample space is called the event. Okay. So when you are consider the experiment tossing a coin 2 times. So what is the sample space? H, 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 T, T, H, T, T. Now you can take the event as getting a head and getting a tail. Get one event. Getting 2 heads, 1 event. Getting 2 head tails, 1 event. Okay. So that's, you can take any one as the event. Number of tails is exactly 2. This is a corresponding sample space. Number of tails is at least 1. This is the sample space. Number of heads is at most 1, is this one. Second toss is not a head. Number of tails is at most 2. Number of tails more than 2, null set. Any subset E of the sample space is called the event. Any subset of the sample space is called the event. Next, the maximum number of events which can be associated with the experiment is, okay, see, if experiment is repeating for n times, where n is the number of elements in the sample space. So number of elements in the sample space is equal to n1, n2, etc. N is there, a1, a2, an. Now what happened? How many events are possible? Out of this, taking 0 element, 1 element, 2 element, up to n element. So 2 to the power of n. In throwing a pair of dice, write down the 2 possible events, even sum of the numbers. So first of all, pair of dice. How many outcomes will be there in the pair of dice? How many outcomes will be there in the pair of dice? First one, 6 outcomes. Second one is 6 outcomes. So 6 plus 6, 12, or 6 into 6, 36. Which one we need to take? You need to take 6 into 6, 36. Okay. So on the first one, 1 will be there and it will be mapped with all the 6 elements. So it will be like 1, 2, 3, 4, 5, 6. And second one, 1, 2, 3, 4, 5, 6. So 1 is going to all these 6 events, 6. So 36 outcomes are there. So out of these 36, sum of the numbers appears on both the dice is 7. So what are the event E1? 7 should come. On the first one, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. Sum of the numbers of an appear on both the dice is divisible by 3. Divisible by 3. So minimum what happened? Total will be, if you're taking at the totals, actually it is minimum is 2, maximum is 12. Yes or no? 1 plus 1 is minimum, 6 plus 6 is the maximum 12. So now what is, how many are required? divisible by 3. So sum should be divisible by 3. 3 or 6 or 9 or 12. These are only the possible. 3, 1 comma 2, 2 comma 1. Next one 6, 1 comma 5, 2 comma 4, 3 comma 3, 4 comma 2, 5 comma 1. Next one 9, 3 comma 6, 4 comma 5, 5 comma 4, 6 comma 3. Next one 6, 12, 6 comma 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n of E2 is equal to, how many we got? 12, right? 12. Now, if you tell me what is the probability of E2, though I haven't discussed probability, but I want to enter. What is probability of E2? Probability of getting the selected event whose sum is divisible by 3. So total number of favorable events. Any one of these 12 are favorable? Yes. Out of total, how many are there? 36. So this probability is 1 by 3. I haven't discussed probability, but this is what the concept is. Very simple concept. Okay. So you write the sample space. You write the event. Event is the subset of the sample space. Okay. Okay. Next one is occurrence of event. Consider an experiment throwing a dice. Let E denote the event. A number less than 4 appears. If actually 1 had appeared on the dice, then we say event E has occurred. As a matter of fact, if outcome is R2 or 3, we say the event has occurred. Anything satisfying our condition is event has occurred. And the event E of the sample space S is said to have occurred if the outcome W of the experiment such that W belongs to E. If the outcome W is such that W is not belongs to E, that event is not occurred. Whatever you are writing, occurring or not. If it is a part of the or a event, it is occurred. Otherwise, it is not occurred. There are the two things. Impossible events, sure event. Impossible never happens. Sure event always happens. The empty set pi and the sample space S describe the events. In fact, pi is called the impossible event and S is called the sample space is sure event, because when you are writing the throwing a dice, outcome is 1, 2, 3, 4, 5, 6. So I'm writing that sample space as the event. This event is always sure event. One of those things are going to happen. You are throwing a dice and you are taking the event sample space event as the null set. So something is going to happen. So null set is impossible events. So look at here. 1, 2, 3, 4, 6. Let E with the event. Number appears on the dice is multiple of 7. First of all, 7 is not there. So how you will get the multiple of 7? So it is impossible event. Yes. Simple event, you need to quickly need to have the wording on these things. Simple event. Compound event. Exclusive events. Exhaustive events. These are the things we are going to talk about. Simple event. If an event E has only one sample point. Sample point means already I told you. That is when you're throwing a dice. 1, 2, 3, 4, 5, 6. If you take each one of them as the separate thing, that is the simple event. Okay? Only one element will be there in that one. So that is called the simple event or elementary event. In a sample space containing n distinct elements, there are exactly n simple events. See, when you are throwing 2 coins, what happened? Head, tail, tail, head. tail, tail, head, head. These are the four simple events. Four simple events. Compound event is which is not a simple event. Compound event means which is not a simple event, but the subset of the sample space. If the event has more than one sample point, is called the compound. See, I'm not stretching too much on this one because these are self-explanatory. You can read, okay? And for this week, your mostly exam syllabus must be on the complete permutations and combinations, okay? What is the sample point? Simple event beta. Whatever the experiment you are doing, each and every simple outcome is the sample point or simple event. When you are throwing a dice, 1 or 2 or 3 or 4 or 5 or 6. If you are picking a playing card, 52 cards will be there. Picking each card itself is the simple event or sample point. Why somebody is showing monkey? Charan, why are you showing monkey? Sujan want to offer coffee to me. Offer some eye drops better instead of coffee. Seems somebody is showing the rains. Raj Siddharth seems to be is taking the shower and listening the class, I think. Huh? Or it's outside raining. Right. All these things only couple of days. Once you come here, na, I'll tell you. Because before you people are leaving, I told you if the online classes comes, what are the things how you are going to study? Everyone in this class, most of the people promise me that you will do make everything. So I'm going to check the notes. The first thing I'll do is I'm going to check your notes. Okay, I'm going to check the notes first. Because you cannot say last time you people said no, we didn't understand or we didn't maintain the notes, etc. But already you got experience this time. Okay. And in this class, people who were going for the means a homesick called as you went for the homesick, no, actually went as a homesick, and then it is turned into the this lockdown. I told you better you carry your textbooks and they may come at any point of time. Right. So compound event is this one. Okay. Algebra of events. So this is more like your set theory, beta. A quick recap on your set theory type of thing. Complementary event. Okay. Uh, frankly speaking, this complementary events. Yeah, somebody is suggesting to remove the virtual background. Okay, let me. Okay. My this one also I'll make it dull. Yes, this is better. What is the complementary event? Complementary set. So this is the sample space. This is the event. Complementary event is A bar or A dash or AC. Okay, that is sample space minus A. In the set theory, you'll write complementary set. Means set A is getting at least one head when you are throwing at two coins. A complementary, getting no head. So this is the sample space or universal set. In the set theory language, it's a universal set. This is A. So the rest of the things are A complement. S minus A is the complementary set. Complementary set. For us, sets are not completed in class 10. It was there better. Otherwise, you look at here, you'll understand. It's a simple chapter. Okay. So this is total set, universal set minus set A. You will be getting the complementary set. Next, event A or B. Event A or B. So that means A union B. What is meaning of X belongs to A union B? X belongs to A or X belongs to B. If X is there in A or X in B, no problem. So here this is the sample space. This is A. This is B. You are going to get this one. And N of A union B. Number of elements in A union B is equal to N of A plus N of B minus N of A intersection B. Why? Because this is in A, this portion is coming, in B is also coming. So we are considering twice this one. So I'm subtracting once. Event A and B, that is A intersection B. A intersection B means when you are writing this one sample space, this is A and this is B. X belongs to A intersection B. That means X belongs to A and X belongs to B. So which is this one? This is the intersection. If A intersection B is a null set, if A intersection B is a null set, we call A comma B are mutually exclusive. Mutually exclusive events. Means occurrence of one event preventing the occurrence of the other event. Okay, mutually exclusive events. If A intersection B is equal null set. Here A union B is equal to sample space, then we call it as exhaustive events. Exhaustive events. So union of two sets is the sample space, that is called the exhaustive events. So A or B, A and B. This is A union B. This is A intersection B. Okay. A but not B. A, it should be A but not B. So that is, we call it as, we can say it as A union B prime, you can write, or you can write A minus of B you can write, or you can write A minus of A intersection B we can write. And number of elements of A union B prime is equal to N of A minus N of A intersection B. Okay? Neither A nor B. Neither A nor B. So neither A nor B is A union B whole complement, or which is equal to A complement intersection B complement. So neither A is possible nor B is possible. Okay. So number of elements of A bar intersection B bar is equal to number of elements in S minus number of elements in A intersection B. And please understand one point here. If B is subset of A, N of B, A minus B, N of A minus B is equal to N of A minus N of B. Okay. So when we are going to a complementary event, we need to write. Okay. So here, what is this question? Consider the experiment rolling a dice. Event E is getting the prime number. Event B is getting the odd number. Event, write the sets representing A or B, A. Please do this one. Please do this one. So first you write the sample space completely. Yes, how many of you got the things? So, right. So simple A is equal to, what is A? Getting a prime number. Prime numbers, what are the prime numbers? 2, 3, 5. What is the B? Getting odd numbers. So 1, 3, 5. So if you write the things is, this is A, this is B. Common is 3, 5. In addition, 1 is there, 2 is there, 1. So what is missing here? 4 and 6 are missing. A or B? 1, 2, 3, 5. A and B, 3, 5. A but not B. Not A. 1, 3. Oh, why 3 will come? Not A. One, 4, 6. So number of elements in sample space is S. So number of elements in A is equal to 3. Number of elements B is equal to 3. Number of elements in A union B is equal to 4. Number of elements in A intersection B is equal to 2. Number of elements in A minus B. How many? 1. Number of elements in A bar is equal to. You can write the probability. Total favorable cases by total number. Automatically you'll get the probability. Okay. So probability is comparatively easy, and only one thing is you should be perfect with the permutation combination. Yes. Equally likely events. What is meant by equally likely events? Events are said to be equally likely when no particular event performance to occur in relation to other event. Means there is no reason why event A is going to. Now, when you're throwing a dice, outcomes are 1, 2, 3, 4, 5, 6. So all these simple events will have the equal chances or not. Is there any specialty like that one? Means, is there any biasness? 2 is going to happen more, 3 is going to happen more. No. If the dice is perfect, unbiased dice, everything is equally likely. So there is no, when you are tossing a coin, both head and tail are unbiased coin, there is no problem. But if you keep some more weight towards the head side, so automatically when you toss the coin, heads will come down because it's more weighted. So it is not equally likely. Okay. So unbiased kinds, when you are taking, equally likely means you need to go ahead with. Okay. Means there is no special reason why you are. See, somebody is, I don't know whether you have this habit of, in our childhood in villages, some people, they'll play with kinds. Okay. Head and tail, head and tail. Okay. And you people might have missed that one in the earlier days when our childhood, we go to the movie, no? In cinema hall, in before the cinema hall, they'll put that one and dice and throwing. Okay. 1, 2, 3, 4, which they'll keep on playing this one, which is not good. Don't do. So in that one, what happened? There is no biasness. There is no guarantee that this is going to come. So our Virat Kohli is there. If there is anything, no, Virat Kohli would have called every time success. He is the guy who is missing the this tossing, one of the bad fellow, always loses the toss. Okay. So what is, there is no guarantee. Why he is calling head or why he is calling tail? No special, nothing is there. Okay. So such, when you're no special reason or no special thing is there to call head or tail. So that is the equally likely events. Yes, if there is some biasness, automatically they are not equally likely events. Mutually exclusive. There is no intersection between two events. They are mutually exclusive, or disjoint, or incompatible events if A intersection B is null set. Okay, right. Exhaustive events. So union of the events gives us the sample space. That is called exhaustive events. Okay, right. Please look at these questions quickly. Please look at these questions. Please make it faster. 4 questions. Please make it fast. Yes. What's the doubt, beta? Just a minute. A or B or A and B? See, X belongs to A or B. Means what is, if X belongs to A or X belongs to B, any one of them, then it will be belongs to this one. X belongs to A intersection B means X belongs to A and X should belongs to B. So if you take a sample space here, this is A and this is B. A union B is, this is A union B. And this is A, this is B, this is A intersection B. This is A intersection B, this is A union B. Yes. Don't ask anything, Nana. Now revision time, when anyway you people are coming, no, I'll tell you how to read and etc. No generalization for the revision preparation. It depends on each and every individual. Okay. Hopefully you people are coming in weekdays time. Let us hope. And I'll tell you how to each individual, I'll suggest you. Okay, after speaking to you people. Yes. So let us quickly look at what are the questions here. Suppose three bulbs are selected random from a lot. Each bulb is tested and clarified as a defective. Sir, but last time college some student tested. Alright, better leave those things better. Okay. Suppose three bulbs are selected random from the lot and tested and classified as the defective, non-defective. Write the sample space of this one. So defective, non-defective, how it will be. A coin is tossed, if the outcome is hit, a dice is thrown. Yeah, and if the die shown up even number, then the dice is thrown up. What is the sample space? So first your coin is tossing up. If tail comes, no problem. If head comes, you need to throw the dice. Either outcome is even number, either 2 or 4 or 6. Again, you need to go for the dice 1, 2, 3, 4, 5, 6. If the odd number comes, nothing. We cannot leave. So this is tail, H1, H3, etc. will be there. Okay. So for this one, I'm showing you the answers. I think there is a one more question. Fourth question is this one, referring to fourth question. What are the things? And these are the answers are there. Please take it. Just check whether you got the correct answer or not. Because these many we cannot write now. And you just look at it. Right. We are getting into the definition. This is called the classical definition of the probability. What is that one? If an experiment result in total of m plus n outcomes. So out of m plus n outcomes, if m are favorable to us and n are non-favorable to us. So these all m plus n outcomes are equally likely, mutually exclusive and exhaustive. Then this is probability of the event is number of favorable events by total number of events. So probability of sample space will be equal to 1. Probability of A is equal to like m by m plus n. Probability of A bar, favorable or non-favorable, will be n by m plus n, which is equal to 1 minus m by m plus n, which is equal to probability 1 minus probability of A. So probability of A is always lies between 0 to 1 because m is always lies between, and probability of A plus probability of A bar is equal to 1. Okay. So number of favorable events by total number of events is called the probability. This is the classical definition of the probability, where these are all simple, equally likely simple events. Okay. How many are favorable? How many are non-favorable? That's it. Okay. Right. So just there are the 52 cards are there. Generally, how many cards will be there? 52 cards. We'll call it as a set of cards. In that one, 4 suits. What are the things actually? Look at your pack of cards will be 52. Out of that one, black color 26, red color 26. In black 26, there are 13 spades, 13 clubs, 13 red color, 13 hearts, and 13 diamonds. So these 13 cards also, how it will be? 2 to 10 cards will be there. Then A will be there, J will be there, Q will be there, K will be there. So these are 9 cards and these are C. So actually in this one, these 3 are face cards also people call. Because on these there are the faces and A nothing will be there. It's given as A only. Okay. King, Queen, Jack, Ace. So these are the things. Face cards. Face cards contain J, K, Q, J. Designed as the things as a face card. Okay. It contains all face cards, also card marked as A is honors card. So there will be 16. Then JQ is called knave cards. Okay. So it's not that much is required. Just you should have the basic idea of this one. Right. So what is the basic probability? Number of favorable events by total number of events. An old man, while dialing a 7-digit telephone number, after having dialed the first 5 digits, suddenly forgot last 2. But he remembered that the last 2 digits were different. On this assumption, he randomly dials the last 2 digits. What is the probability that the correct telephone number is dialed? So 1, 2, 3, 4, 5. Over, no problem. This one, he dialed everything perfect. But these 2, he knows these are the 2 digits, different digits. So number of ways he can pick up this one. So here the first place he can type any 10 ways and the second one is 9 ways. And the probability that the correct telephone number is does. So what is the possibility? Only one is the correct option, right? So 1 out of 10 into 9. 1 by 90 is the answer. One by 90 is the answer. See, because first 5 dials, 5 numbers he dialed properly. 6th and 7th he forgot, but one thing is no clear to him that these 2 are the different digits. So number of possibilities, writing, typing or dialing those 2 different numbers. The first one is 10 ways, the next one is 9 ways. Out of this one, how many are favorable? Only one way of dialing will be done, right? So 1 out of 90. 1 out of 90. Any doubt in this one? So here what happened? See, there are the 2 cases. What is number of ways of dialing the last 2 digits? This is the permutation only and favorable cases. Next one. 4 apples and 3 oranges are randomly placed in a line. Find the chances that extreme fruits are both are oranges. So total number of ways, 4 apples and 3 oranges. Placed in how many ways? So 7 fruits are there, 7 factorial. Okay. So shall we take these one as identical, then it will be 4 factorial into 3 factorial. Now here orange is there, here orange is there. So now how many fruits are there? 5 fruits are there. 4 apples plus 1 orange. This can be done in how many ways? 5 factorial by 4 factorial. So 3 factorial is 6 by 5 factorial, 7 factorial, 6 into 7 is equal to 1. Now let us say if the apples and oranges are apples internally different, oranges internally different, denominator will come 7 factorial. Now here 2 oranges. You select 3C to arrange them in 3P2 ways. So that can be written as 3 factorial ways. Now 4 apples and 1. So that can be done in how many ways? We can write 5 factorial ways. Are you getting the same thing or not? Yes, you are getting the same thing. 2 natural numbers are randomly selected from the set of first 20. Find the probability that their sum is odd. So number of ways of selecting 2 natural numbers from 20. 20C2. Sum is E odd number. So 1, 2. Sum is odd. So what is the case? Even plus odd or odd plus even. These are the 2 things. So what I'll do is, first number I selected 20 ways. When come to second one, only 10 cases are there. How can you say? So first one even or odd doesn't matter. If the first one is even, I'll take the odd number. If the first one is odd, I'll take with 7. So 20 into 10 by 20 into 19 by 2. Is it? No, somewhere I missed. See, look at it. 2 numbers are selecting randomly. So that is can be done in 20C2 ways. So now 10 even numbers are there, 10 odd numbers are there. So this can be done 10C1 into 10C1. So there is no first one, there is no second one. Okay. Just to try one.